Hello everyone, today let's take a look at Quantipus number 44, which is a relatively straightforward combinatorics question. We have a committee of 8 dogs that is chosen from a pool of 5 golden retrievers, 6 German shepherds, and 4 poodles. So what's the probability that this committee contains exactly 2 golden retrievers, 3 German shepherds, and 3 poodles? So this is just a little drawing. Our 5 golden retrievers, our 6 German shepherds, and our 4 poodles. And when we add all these dogs up, that gives us 15 total dogs. So we know that when we're solving any counting problem, basically the probability of something is just going to be the number of outcomes that satisfy our condition right here divided by the number of total possible outcomes, right? So what exactly are our total outcomes? Well, we have 15 total dogs and we're choosing 8 for our committee. So our answer is just going to be 15 choose 8. And just a brief aside, 15 choose 8 because we have 8 dogs for our committee represented by these lines right here. And any of the 15 dogs could be in the first position in our committee, then 14 for the second position because we've already chosen the first one, and then 13 for our third position all the way down to 8. So this is just equal to 15 factorial on 7 factorial, right? We have to multiply all these up. And then since we're just choosing a committee, we don't actually care about the order of these dogs, right? So we have to divide by 8 factorial because that's the total number of permutations for these 8 dogs. And this is just equal to 15 choose 8. That's the exact formula, right? So that was for our total, but now let's look at our restricted view where we have exactly 2 golden retrievers, 3 German shepherds, and 3 poodles. So for our restricted view, let's first look at the golden retrievers. We have 5 total golden retrievers and we want to choose 2 of them. So if these are our golden retriever positions right here, so this is obviously just going to be 5 choose 2, right? We have 5 golden retrievers for our first position, 4 for our second. That's going to be 5 factorial on 3 factorial, and we're going to need to divide by 2 factorial because there's 2 ways to permute 2 elements, right? So divided by 2 factorial, which is exactly this. Now for our German shepherds, well, we need 3 of them. So again, we have 6, so this is going to be 6 choose 3. I won't work it out again. And for our poodles, we have 4, and we need to choose 3. So that's just 4 choose 3. So this one's just going to be equal to 5 times 4 on 2, so that's going to be 10. This one's going to be 6 factorial on 3 factorial, 3 factorial. So this is going to be 6 times 5 times 4 on 3 factorial, and then this is 6, so this is going to cancel out, so this is going to be 20. And 4 choose 3 we know is just 4. So for the total possible outcomes in our restricted space, we just multiply these 3 things together, so we get 10 times 20 times 4 divided by 15 choose 8 for our probability, because this was our total, right? This is just 800 on 15 choose 8, which you're going to need a calculator for. And then when you simplify that, you're just going to get 160 on 1287. So that's going to be our final answer here.